Let's start by importing the asset. Open the package manager, search for Cineaster, and import the package. Accept the dependencies so the correct version of Cinemachine gets installed. Let's click Import. Done. Cineaster is now available in your project, as we can see here in the menu. Before creating anything, it's important to understand Cineaster's workflow. As we saw earlier, when initialized, a Cineaster manager is created for the current scene. This manager is responsible for holding the list of cameras added to the scene. Each camera can have multiple takes and triggers. The take or group of takes is used to create cutscenes, where you configure parameters like duration, dolly track, target animation, events, and so on. It's also worth mentioning that the take's core file is a timeline asset, meaning it's fully compatible with Unity's timeline window. Finally, trigger areas, just like the name suggests, are used to activate cutscenes based on the user's needs. Let's start by creating our Cineaster manager in the current scene. In the main menu, go to Casado Cineaster and click on Show Manager to open a window. Now let's initialize Cineaster in this scene by clicking Init. This will add a Cineaster manager object to the scene, which controls all cutscene elements. Inside it, we have the main camera, which will be the primary camera for this scene. Note that the previous camera was automatically disabled. The next component is the state-driven camera, which will manage the camera rig used in our cutscenes. Next, we have the routes for takes, targets, and triggers, where the game objects of the respective cameras, their takes, and triggers will be added. Let's add a cutscene camera by clicking on New Camera. We can see that a new virtual camera has been added to the camera rig, along with a default target. If we already have more than one cutscene camera and want to switch between them, or even define which one will start the scene, we just need to check the Start field on the desired camera. That one will be highlighted with the default state color. Inside the Camera tab, we'll find the basic settings, such as the virtual camera reference, the state name, which we'll soon see how and when to use, and the update method, which is the update mode the main camera will use when this cutscene camera is active. If no take is created for this camera, then the target, confiner area, and field of view settings will be used. Let's do a quick demo with these two static cameras. We can show or hide the header of the Cineaster window by clicking here. Let's use that to save some space. As we can see, we're using the basic camera settings on both cutscene cameras. Now, let's take a look at how to create a take. Let's start by creating a new cutscene camera. In the Takes tab, we're going to add a new take by clicking the plus button. Here in the tab, we can see that a dolly track, dolly cart, and a take target were created, each under their respective routes in the hierarchy. The dolly track uses a path, and we can either use some presets to speed up our workflow or choose a custom option, which lets us draw our path the way we want. For this quick explanation, I'm going to select the simple line path. It's basically a short path with just 2 points. As we can see, it's very simple to manipulate this path by clicking the sphere points and positioning them wherever we want. This is the path that our dolly car will follow while looking at the take target. Here's a quick tip. We can select both the dolly track and the take target directly in the scene by clicking on their object icons. Moving on, still in the Take tab, we can use the mini player to get a preview of how things will play out when this take is triggered. We can also enable loop mode if we want this take to play in a loop. Still in this mini player, we can view and edit the total duration of the take. For more precise control, we can click the shortcut here to open the timeline window directly on this take's timeline asset. If you're not familiar with the timeline window, don't worry. Its workflow is very smooth and intuitive. Inside the timeline window, we can follow the playback, have better control over a specific moment in the take, adjust the duration, and add more actions to run alongside it. For example, animating a character. Feel free to explore all the features the timeline has to offer. Just check out the documentation for more details. Let's expand the Take tab again and explore a bit more of the settings and features available for the take. In the Settings tab, we can change the name of this take. Choose whether this take should play immediately when this camera is triggered or with a delay. Set the field of view that will be used by this camera during the take. Configure the type of follow and look at target. Choose between a simple target or a group of targets. You can even change the target for this take. Adjust body and aim parameters, which are basic settings we have in Cinemachine virtual cameras, such as damping, offset, etc. We can enable a shake effect, where you can use the native Cinemachine shake profiles or create a custom shake. To set the values, just click the plus button. We can also add a confinement area to this camera. Just enable the confiner area option and assign a collider that will limit this camera's movement within the area of that collider. We can add a simple fade in and fade out effect for the current take. We can enable the skip action, which allows the player to skip this take while it's playing. Just enable it, Click on Edit, and you'll see the configuration asset for that skip. In the timeline window, you can edit when and for how long this listener will be active. To configure it, first decide when to allow the skip. If you want to enable it right away, simply check the Allow at Runtime option. Alternatively, you can call the function Cineaster.enable skip for take to enable this listener manually. Next, define the skip mode. You can use the skip to end mode to jump to the end of the current take. When using this mode, the system will respect the settings for next camera and next take that are already configured in the current take. Or use a jump to target option to jump directly to another camera and another take. In the input type, you can choose to use a key or a button to trigger it. And of course, make use of the events that are called at key moments in the skip asset. Moving on, we have the option to change the dolly track and dolly cart used in this take, and even assign a parent for the dolly track. If we turn off looping, we can set which camera and take to go to after this take finishes playing. And to demonstrate that, let's create a new camera and a new take to make a quick cutscene. Done. Now we can go back to our first camera, to the take we already had, and set it to go to this new camera and take we just created. Let's increase the duration of this take to 6 seconds. And enable and set up skip for this take using the escape key. We'll also set this camera and take to be the one that starts the game. So let's hit play. Now I'll press the escape key, and as we can see, it jumped to the next configured camera and take. Moving on, let's set the second camera at the end of take 1 to go to take 1 of camera 1. As you can see, this creates a loop where one triggers the other. It shows that you have the freedom to build your sequence however you want and define the skip rules easily with just one click. If you look closely, our take target in this example is already pre-animated. I did that using the Animate Target tab, which is made specifically to simplify this process and create a quick animation for your take target. It's worth noting that using this tab is completely optional. If you prefer, you can animate your target manually or even reuse an animation you've already created. For the sake of explanation, I'll delete this quick animation I made to better show the two main ways to animate a take target. The first option is to create a simple, standalone animation where the target isn't linked to this take's timeline asset. The second option is to animate it directly within the take's timeline asset, and this is the method I recommend. This way, you can animate the target and ensure that the animation playback stays fully synced with your take, avoiding timing issues later on. To use this second option, the process is very simple. Just click on Vinculate to take timeline. After that, we'll explore a few quick tools, like animating the take target to follow the path defined for this take. If your path is a loop, you also have the option to make the target move in a loop along that path. And finally, there's a shortcut to open the timeline window directly, making it easier to adjust or create your animation. In the Events tab, we can set up different events that will be triggered automatically at specific points during the execution of the take. Like the on-init event, it's triggered right when the take starts. And also the on-end event, triggered when the take ends. The after transition event, on the other hand, is only triggered after transition from this take to the next one, but only if you're using a transition type that has a duration, like ease in out, linear, etc. If the transition is a cut, this event won't be triggered, because cuts are instant and don't have a transition phase. Let's do a quick example. I'll set up the scene's directional light to turn off when the take starts, and turn back on when the take ends. If I want, I can also add an action to the after transition event, as long as I've set up a time transition between this take and the next one. Important note about skip. If you enable skip for this take and use a skip to end option, the on-end event will still be triggered, even when skipping. I'll hit play again and press the key I set to trigger skip for this take. In my case, it's the escape key. And as we can see, it jumped to the next configured take, and the after transition event was triggered, turning the directional light back on. However, If skip is set to jump the target, the on-end event won't be triggered. Since the take is simply skipped, jumping straight to the final target without running the ending sequence. And finally, in the FX tab, we can easily add an audio clip to serve as a background track during this take. Just like the other features we've seen so far, this step is also completely optional. To demonstrate, I'll quickly create a new take on camera to and add an audio clip that will represent the sound of a portal being activated in the game. Using this feature is very simple. Just enable the audio option and create a new preset by clicking the plus button. From there, we can choose the audio clip we want to use. In my case, I'll select a sample audio just to show the process. We can also define the start time and duration of the audio within the take. In this case, I'll keep the default values, since I want the sound to play right when the take starts. In addition, we have other useful settings, like the loop option, if you want the audio to repeat, and even an option to create a volume animation curve, controlling how the audio volume changes over the course of the take. Before testing the final result, I'll also add a fade effect to smooth out the transition. Done. Now let's see how it looks. Now let's explore a classic feature in games, the trigger area. It allows you to activate a cutscene automatically, for example, when the player enters a specific room. Of course, you can build this system your own way, but Cineaster offers a practical and powerful way to handle it. With the trigger area, you can define the layer used for detecting collisions, choose which camera take will be played, and configure the type of transition that will be applied. Additionally, in this configuration tab, you'll also find some useful shortcuts to speed up the editing of the collision area. You can quickly switch between box collider and sphere collider with just one click, and precisely adjust the area size directly using the X, Y, and Z fields. But if you prefer, these adjustments can also be made manually in the scene view by dragging the area's handles directly in Editor. You also have full control over when this area starts listening for collisions. You can enable it right away. With a delay. Or through script in a very flexible way. You can enable the trigger area via scripting in two ways. The first is by directly calling the method trigger area manager that enabled trigger area via scripting in code. In this example, I've set it to be called when the T key is pressed. The second method uses a listener. In this case, You assign a game object in the scene that has a script with a field, which can be a Boolean, a number, or even an event. When a condition configured in that field is met, the trigger area will be enabled automatically. In this example, I declare an event and set it to be invoked when the R key is pressed. As we can see, as soon as the action was executed, the trigger area was successfully enabled. Entry action. To configure the entry, you first define the type of action. Immediate, to happen right when the collision is detected. Or with a delay, if you want some time before the action starts. Then, you choose a detection mode. On-enter detects only when entering. On-stay checks while the object remains inside the area. Or both, which is useful when the target is already inside the area before it gets enabled. Right below, you have the event option, which works just like in Unity's standard systems. These events are completely optional, but they give you a hook to run a custom action at the exact moment the trigger is activated. And if you want, there is an option to completely destroy the trigger area after executing the action. This option removes the object from the scene, which is useful when you know the area will only be used once. Exit action. It's also possible to configure behavior for when the target leaves the area. This won't always be necessary, but imagine the following scenario. The player enters this trigger area, triggering the cut scene, but then leaves the area, and you want a main camera or another camera to take back control. In this case, the exit action solves it perfectly. You define the type of action, and you also have an optional event, which works the same way as the entry event. It indicates the moment the exit happened, in case you want to use it to trigger any behavior in your game. And you can also set which camera and take should be executed after the exit. Re-enable the trigger area. Finally, there's the Enable Trigger Area on Exit feature. This option is used to re-enable the area after the player exits. By default, whenever the entry action happens, the trigger area is automatically disabled. So, if you want it to be automatically enabled again on exit, just activate this option.